Okay, we're going to quickly review the heart box. So if you want to follow along with me, I'm just basically doing the instructions from 431 in a shortened manner. This is from PBS, and we already did this, but obviously we probably didn't save our papers from last year. So quick review, draw this on your paper, and then you'll be able to turn it all in at the very end. So remember, your heart is backwards than what it looks like in real life. Um, So that's why on your paper I have both versions of your heart box, and then I have an actual picture on there of the right and left atrium. So here is the picture right here. So this, if you were standing, it would be like your head would be up here, your arms would be over here, and your feet would be down here. So this would be like looking into your chest. So if you were to take your paper and lay it on your chest, and then pull it off and flip it over and look at it, that's why it looks backwards. So just know that really, in real life, your right side's on your right side, but on the paper, the right side's always going to be on the left side. It's kind of weird, but we're going to start by labeling. This is the right atrium, the left atrium, the right ventricle, and the left ventricle. So blood always enters in here into the right atrium. It moves through the tricuspid valve, down through the pulmonary valve, and it travels through the pulmonary valve to the lungs. Pulmonary means lungs, so this would be your lungs. Okay, and it travels through the lungs via the pulmonary artery. Arteries are basically what carry your blood away from your heart. So if you think about an artery carries you away from your heart. If you look at your diagram, you'll notice that the blood actually enters the right atrium through the tricuspid, does kind of like a U-turn at the bottom, and exits the top of your heart through the pulmonary vein. So just notice that in our picture, it is coming in, exits, goes to the lungs at the bottom. So just know in real life, it's more like this, but in our picture, it's just a simplified version. Once it gets through the lungs, it picks up some oxygen, and it travels back to the heart via the pulmonary vein. So veins are what bring the blood back to the heart. It enters the left atrium, passes through the mitral valve into the left ventricle, and exits the left ventricle via the aortic valve into the aorta, where it is transported to the body. So this big vein here, which I kind of drew funky, is the aorta. So the aorta is really on the top of your heart, and it has that characteristic 3 little branch thing. So once the blood comes through the pulmonary vein, it actually enters through the left atrium, through the mitral, does kind of U-turn at the bottom, exits kind of underneath the pulmonary artery, and kind of goes underneath that and up into the aorta towards your body. So that's the real pathway it takes. Once it gets to the body, it dumps off all its oxygen, and it's sad, and so it has to come back to the heart, where it returns via the vena cava. There's actually 2 vena cava. There's the superior vena cava and the inferior. So superior means top, and inferior means bottom. So just know that one of them enters the top, one of them kind of enters at the bottom. So here would be the bottom one. This would be the inferior vena cava. And this right here would be the kind of superior vena cava. And they kind of come together, and they come to like a little come to Jesus meeting right there in the right atrium. They enter in together, and then dump into the right atrium. So there's some electrical communication going on in the heart. It starts at the SA node. The SA node is kind of just, it's the sinoatrial node. It's where the electrical communication starts. It's kind of like action potentials way back from neurons in your brain. Remember those kind of like send a signal down the neuron, and it tells your body to do different things, and there's like a gates that open and close those. Remember the sodium and potassium pumps that open and close and allow that signal to pass on. Same thing's kind of happening here in your heart. There's an electrical communication going on. So as soon as that blood comes into the atrium, it gets hits that SA node, and it gets really excited. And it's like, hey, let's do something. And so it sends a signal over to the AV node, or the atrial ventricular node. It's kind of located right here on that little area in between both ventricles. Once it hits that, sends that signal over. That signal travels down the inner wall of the heart right there. It's called the bundle of His. So it hits this, and it kind of travels down this little wall, and then it sends the signals up both sides of the heart. So it hits that bundle of His, it branches off to the right and to the left, and then it travels up. There's these cool fibers along the way on each side. They're called the Purkinje fibers. Those Purkinje fibers basically are what are contracting the heart. So once that signal hits that Purkinje fiber, it basically tightens up and causes the heart to contract, and that's the actual beating of the heart. So just like in your brain, when those that signal travels along the action potential, it gets that signal and it knows to open its gate and pass along, and it knows to cause different things of your bodies to move or whatever signal it's trying to communicate with your body. Same thing's happening in your heart. As soon as that signal travels across from the SA node to the AV node down the bundle of His, it hits those Purkinje fibers, and that signal says, hey, let's contract and let's tighten up, and that causes that blood to be forced from one place to the other. So that's basically the movement of the heart and the blood of the heart. So now you should be able to answer some more questions, like number 2 about the role of the valves in the heart. The valves are very important. They're like little floodgates. They open one direction for a reason. They allow things to move through and not back up backwards. If you have a leaky valve or something like that, sometimes it's called a heart murmur. As you get older, sometimes your valves get a little relaxed and you have a little bit of a leaky valve. It's not terrible. It just means maybe you are a little more tired. Maybe you don't have as much oxygen in your blood, things like that. You should be able to answer number 3 about the movement of that electrical impulse, which is that yellow signal I drew on there for you. Number 4 about pulmonary circulation and systematic circulation. Just might want to do some Googling and researching on that one. And then the last one about number 6 about the electrical communication in the heart and how it's similar, or how it compares to the communication in your muscles. So that's, how does this electrical signal, that yellow pathway I drew, how does that relate to neurons and movement? So how does that compare? So once you get these questions answered and you have this drawing drawn on there, you may turn it into the tray, and I'll be back tomorrow.